Yeah, hello and welcome back. Uh, the second problem that we are going to solve is something like this. We have to remove the duplicates from sorted array. Okay, so basically, you are given an array, suppose consider this one. Okay, and you have to remove the duplicates from the array. So the second 0 over here and the 1 in the index 3 and 4, these guys are uh, repeated, are not unique. Okay, so these elements are to be removed and you have to make the array look like it only contains some unique integers. Okay, so uh, that is what our job is, but we have some constraints as well. So it is written that do not allocate extra space for another array, and you must do this by modifying the input array in place. Okay, but let's ignore this as of now. Let's begin with actually using some extra space. And yeah, so you will understand why I am insisting on using that at the beginning. So by using extra space, this problem really becomes pretty easy. So suppose your array is 0 0 1 1 1 2 2. So what you do is simply uh, starting from the second element onwards, because you can always skip the first element, because if you think carefully, that the first element is always going to be unique, right? So if there is only one element in the array, that one is always going to be unique. To get some duplicate values, you need more than one. That is as much simple as I can put it, like so you can ignore the first one and begin the process from the second one. And from the second element onwards, what you have to do is um, check that whether the current value is equal to the previous value or not. As simple as that. So you are using an extra space, suppose that is a vector, and you can always copy the first element directly without bothering about anything. But as the second element is exactly as the previous one, so we are ignoring that. Okay, now let's go on to the next one. Compare with the previous one, it is different, so we add 1 to the vector to this one. Compare, same as the previous one, so ignore this one. Also we are ignoring this one. As we compare, comes out to be unique one, so we put 2 over here. This one, compare, the same. Okay, so simply put, this could be our returned array. But if you look carefully, that here you can see the return type is integer. Okay, so what basically happens is you are expected to return the number of unique integers. Okay, so in this case you are expected to return 3, right? Because 0 1 2, they are 3 in number. So when you return 3, what the system will check is only the first 3 elements of this array. Okay, but you have not done anything to this previous array, so previous elements, to this first 3 elements, sorry. So you need to do that. So what you do is simply replace this. Let me copy it down again, 1 2, and the array that you found is 0 1 and 2. So you need to simply replace these values over here. Okay, so let me do that. It simply becomes 1 and 2. So you are doing nothing but modifying these first 3 elements in this array returning the value 3, the system will check only these first 3 elements. It gets 0 1 2, the system is happy. Okay, so let's see that in code now. So we need an extra vector. Let's say it illegal array. Okay, because we are not allowed to make this space, allocate this space. So the first element is always going to be copied. Nums jumps nums I. Then we need to iterate over everything, every other, and we need to start from the second one, right? Nums dot size I plus plus, and okay, so we need to give this bracket. So if and now we have to compare the current element with its previous one. If nums I is not equals to nums I minus 1, that means it is a unique, so unique element, so we need to push it into the illegal array. Dot push back nums I. Okay, now we have done our job by using the extra array, but the second part, that is this thing, we need to push it back. We need to replace the original value with some modified values. Okay, so here comes that thing, I equals to 0, I less than illegal array dot size, then I plus plus, and you need to just replace the value in the original array by this thing, and we need to return the number of unique integers, which is legal array dot size. Yeah, and one more thing, that we assume, okay, this should be 0 na, pushback num 0. Yeah, so we are considering that from the first line of code that the array must contain at least one element, but it may not be the case also. So in that case you may face some error. To avoid that, we need to put some condition that if nums dot size double equals to 0, we need to return 0, or I can use my favorite thing also here, nums dot empty. That's smart. Okay, so we are ready to go. Let's see if we face some error. No, nothing. Oh yeah, I checked for it. Let's see. Yeah, it's great, and let's submit. 98%, but see this memory usage thing, 5.69%, that is pretty poor. Okay, so you may not be happy, yeah, because we are using some extra space, but we are not allowed to. So to avoid that condition, I am going to show you how can we avoid using some extra space. So here I am copying it down, the elements of the array again to say. Okay, now follow carefully that the first one is always going to be a unique element no matter what. From the second element onwards, we need to check that whether this element is unique or not, that whether this element is at its right position or not, or putting differently, that if this position has the right value in it. Okay, so in this array there are three unique elements, right? So 0 and 1 and 2. So in this first position 0 is already there. In the second position it is 0, but it has to contain the next unique element present in the array. Okay, so it must contain 1. So to do that, uh, we need to follow a method called two pointers. Okay, pretty bad handwriting, huh? Two pointers, nothing. We simply consider two elements I and j, two counters, sorry, I and j. They increment following different rules. Okay, so the they have two different jobs. Okay, the job of I is to uh, count the number of unique elements, and the job of j is to find the next unique element. Okay, it will get clear as we will mm, see this demonstration. So let's say, okay, let's use black. So we begin I from here and j from here. We continue the loop until j goes out of bound. Okay, so out of the this array region, array elements. Until that we will iterate over j, and there may be two conditions, that the elements at I and j, they are equal, and the second possibility is they are not equal. So when they are equal and they are not equal, okay, so see, when they are equal, we do not need to bother about anything. We simply need to increment j. Why? Because we know that this element where the current j is pointing towards has a repeating element, and our I is already in a safe place, and that is holding the number of unique elements found until now. So until now we know the first position is always going to hold the first unique element, so 0 is held at I, so no worry there. Okay, so we increment j and go over here, it is j. Okay, now we check I and j, and we see that they are unequal. So when this situation occurs, then we need to okay, so when j and they are equal, so we need to simply j plus plus, and when they are not equal, then we need to follow three steps. Step 1 is we need to increment I, so that I goes to the next position where there is a repeating element. Okay, second one, we need to exchange the elements at I and j. Okay, so j is holding the next unique element and I is holding a repeated element, so we need to exchange that, so that in I the next unique element comes and in j the one garbage value goes. Okay, that we do not really care about. And the third step is we need to do j plus plus. We need to do j plus plus, yes. So the first step is I plus plus, so I goes over here, this is I now. Okay, let's make a good use of eraser. Yeah, I goes over here, these guys are exchanged, 0 and 1, they are exchanged, 1 0, and j plus plus, so j goes over here. Okay, then what it does, it again compares I and j. So these guys are compared and it is saying that they're equal, so simply j plus plus, so j moves over here. Again these two are matching, so do not worry, go over here. Now they do not match, so as before we need to do I plus plus, so I comes over here, And next step is we have to exchange, uh, we need to exchange I and j, right? So I and j, so in j there was 2, so 2 comes over here and 0 goes over here, as simple as that. And then j has to moved over here. Okay, again they are compared and they are equal. As they are equal, j moves over here and j is now out of the limit of the array, number of array. So then we simply break out. Okay, if you have any problem, please let me know in the comments, or you can go back and watch this explanation again by yourself now. But let's move over to LeetCode and see this thing in practice. Okay, so let this condition remain there because we need this condition always. So we need two elements, int I and j. Okay, we need to initialize I at 0 and j at 1 exactly. Then for int, or we can say that while j is actually double equals to nums dot size, then we need to break out, right? While, sorry, while this is less than nums dot size. Let's go full screen, and now what we have, two conditions, that if nums I double equals to nums j, then we need to simply put j plus plus, or okay, let's go this way, or else we need to do three things. Nums, sorry, first we need to increment I, then we need to exchange the values. Okay, I have not built any function, so if you like you can add another function, private. Let's use the OOP, constant sorry object oriented programming concepts. So let's make a yeah, the type is going to be void exchange, and we need to pass the array because the modification needs to be in the array only. Vector int nums, then we need to give the indices as well, I and j. So here int temp equals to nums I, nums j, or nums I equals to nums j, and nums j equals to temp. So we have exchanged the value. So let's use this function here, nums I and j, great. And then we need to increment j plus plus, increment j, yeah, and we need to simply return I plus 1. Why? Because I will be the index of the last unique element in the array. And as we all know that in C++ we follow a zero based indexing. So if there is only one unique element in the array, so I will be 0, but we need to return 1, right? Because the number of unique elements is 1 there. So that's pretty much it. Let's run this thing and see if it gets some error or not. Okay, so let's submit. Yeah, but still the memory usage is pretty much high. Why? Because I think I have used this code and I am using up the stack space. So what to do? Let's bring this guy over here. let's do it. And one more thing, that you know, uh, this J++, we are repeating the code, right? So this is not very um, good exercise. So what can we do? Let's modify this thing. Control X, Control V, and we need this one over here, this guy over here. And J++ is always going to happen, right? So then we can put J++ outside this thing. So every time there will be an increment in J. Okay, so let's submit. Here you can see the memory usage has improved a lot. So that's it. Stay tuned for the next video. Thanks.